On this channel, we provide useful programming information with practical code examples. This time, we will talk about typed array in TypeScript. We will explain typed array in TypeScript, including practical examples. Enabling subtitles will make the code descriptions easier to understand. Typed array is a mechanism for efficiently handling binary data. It is especially useful for low-level binary operations such as large image data, network byte streams, and numeric arrays for WebGL. ArrayBuffer represents a fixed-length region of bytes. First, create a buffer and check its size and byte length. This code creates an empty region of 16 bytes. ArrayBuffer itself does not have read/write functions, so you access it through TypedArray or DataView. TypedArray creates a typed view on top of an ArrayBuffer. Below are examples of creating and using some typical typed arrays. By creating multiple views on the same ArrayBuffer, you can read and write the same memory in different types or granularities. Length of the view is the number of elements, and byte length is the number of bytes. When you write a value to a typed array, the corresponding bytes in memory are updated. You can see the changes when you read the same buffer with a different view. In this example, we write a byte sequence and then read the same area as a 32-bit integer. Note that the output depends on the endianness of the execution environment. DataView is useful if you want to control environment-dependent endianness issues. DataView lets you specify endianness when reading and writing. DataView is a convenient mechanism for reading and writing bytes in detail. It supports a variety of types, such as signed or unsigned integers and floating point numbers, and allows you to explicitly specify endianness, byte order, which is very useful when implementing binary protocols. Subarray of a typed array returns a view sharing the original buffer, while slice returns a new copy. Performance and side effects differ depending on which you use. If you modify the shared view, the original array will also change, which may cause unintended side effects. If you want to safely preserve the original array, you can create a copy in advance using slice. We will explain how to copy data between typed arrays and how to paste parts using the set method. If the element types differ, you need to convert values, such as rounding or range checking, rather than simply copying. Set allows fast copying between typed arrays of the same element type. Here, we introduce a simple parser example which reads a fixed format binary data consisting of a 1-byte type, 2-byte data length, and a following payload. In this example, the header is read using DataView, and the payload slice is created with uint8 array. Endianness and buffer length checking are important. This is a typical example of handling an ArrayBuffer, obtained from a network request using TypedArray. You can directly pass the ArrayBuffer, obtained with response ArrayBuffer, to a typed array. It is used for images, audio, or custom binary protocols. Here are some performance tips and common pitfalls that are helpful to know when using typed arrays. Avoid unnecessary copying. To process large data efficiently, you can reduce unnecessary copying by creating partial views with subarray, or sharing the same ArrayBuffer across multiple views. Be careful with Endianness. For network communication or file formats, the ordering of data, byte order, is often specified. Using DataView allows you to specify the Endianness explicitly when reading and writing, preventing unintended misinterpretation. Be aware of value ranges for each type. For example, uint8 inches can only represent values from 0 to 255. If you input a negative value, truncation or value rollover may occur, so you should define conversion rules as needed. Consider stress on garbage collection. Frequently recreating large ArrayBuffer increases the burden of memory management. In performance-critical situations, you may consider designing the code to reuse existing buffers as much as possible. Typed array is a mechanism for handling binary data quickly and efficiently. By combining ArrayBuffer, which reserves a fixed-length byte area, with typed array, or DataView, which read and write the contents using specific types, you can perform flexible binary operations. Depending on your use case, you can choose between using subarray, slice, or DataView, and design your implementation with attention to endianness and copies. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Your support keeps this channel motivated. Please subscribe to the channel.